The lecture series Programming in C. In this session of this series, we will be learning about function calls and declarations. In the earlier sessions on functions, we have learnt on declaring the function prototype and invoking the functions, the usage of actual and formal arguments, right. We will first focus more on function call types and how to declare functions and how to make use of the functions for usage in this module. So, we have already learned defining a function. We have also learnt that it carries two things, the function parameters and the return type. Also, we have learnt the importance of having function prototypes in case if the function is defined before the main, we do not require function prototype. If it is defined after the main function, we may have to intimate the compiler that what is the syntax to be followed for the function. So, the function prototype is necessary in that case. So, this example also we have learnt in the previous module. This I am just recollecting because we need to again learn about the function call statement level depth. So, that is the reason that I have given the function definition and function prototype declaration here. Okay. So, let us assume that we are defining a function to calculate the factorial of a given number. So, in the main function we are supposed to give a number as input. So, n is a variable which is taken as input from the user and we are calculating the factorial of n. So, according to this example, the value for 10 factorial is calculated. So, if it is to be calculated for 10 factorial, the loop has to run from 1 to n and we need to calculate the product of the given numbers from 1 to n. So, for doing that we need a function. So, we are using a function in which we can see that the parameter name used is m, right. So, here it is n, in the function definition it is m. So, here this is actually called as actual argument or actual parameter and this is called as formal argument or formal parameter. So, here what happens, the value of n is copied on to the formal parameter m and it carries with the function. Once it is copied, it becomes local to that function. So, thereby even if it is going to be updated, the value is going to updated, it will not get reflected in the value of n. Okay. So, that is the reason that we need to use a return statement for returning the result back to the calling function. Okay. Now, we will focus much on calling a function. So, while calling a function, we can see a concept that the actual argument or the actual parameter value has to be copied onto the formal parameter. Then in that case, the data type of the actual parameter should match with the data type of the formal parameter. Also, the position of the actual parameters in the parameter list must also be correspond to the formal parameter list, in the sense that if I am declaring 3 parameters as actual parameters, the same order should be maintained even in the formal parameter. Supposing the first argument is going to be int, I declare 3 parameters, one of integer type, the second of float type and third of double type in the function call. Then while supplying the values to the function as a formal parameter, while calling the function, the values should be assigned in the same order of same data type. So, in this case I should supply the value as 3.0, 3.2, this is how it should work. So, we are supposed to keep in mind that the actual parameters data type should be the same as the data type of the formal parameter. The second thing is the position of the actual parameter should go with the same position of the formal parameter, right. So, here we can see an example taking up more than one formal parameter or actual parameter. So, here this function takes 3 parameters, the first 2 are of double type and the third parameter is of char type. The first 2 parameters should go in position with the function call. So, this is a function call statement. So, here you can see operate x comma y comma op. So, these 3 are now named as actual parameter. The x should be of double type, yes, x is of double type, y should be of double type, y is of double type, op should be of character type. So, op should be of character type. Now, the data type of the actual parameters match with the data type of the formal parameters. And second thing what we are supposed to check is the position of the parameters. So, in case the position of the parameter says that x, y and op, I should follow the same position here also in the actual parameters. The position should not vary, right. Then we are now going to learn 2 concepts, call by value and call by reference. Okay. The call by value concept is that in which the argument of the argument value of the actual argument is copied to the corresponding formal parameter in the called function. So, let us see with an example. So, here this is a user defined function compute sum which takes one parameter, right. So, the parameter which is defined in the function, it is called formal parameter, and when the value is supplied from the function call statement, it is called actual parameter, right. Now, let me go into the function definition. In this function definition, the parameter is named as int n. Okay. So, now this is named as formal parameter, and at the place of function call, this is actual parameter, right. Now, what we are doing here inside the function, let me explain the program. N value is defined to be 3, right, and we are passing that n value to the function call compute sum. So, when this function call statement is invoked, the control is transferred to the function statement. So, here what happens, the n variable or the formal parameter receives the value of the actual parameter which is actually 3. So, now the value of actual parameter is copied onto the formal parameter. Now, it receives a value 3, right. Now, what happens, we are running a loop for 3 times, right, and sum equal to sum plus equal to n. It means that we are adding the values of 3 numbers 1, 2 and 3. So, the output will be 6, the sum value will be 6, right, and we are displaying the value of n inside the function as well as the value of n in the function call place, right. So, what happens here, when you see the execution statement, here the sum value is computed to be 6. After that, if you display the value of n which remains the same, which is going to be 0, because the value of n to be 3 is passed on here to the loop, and every time when you see it is getting decremented by 1, and when it reaches 0, the loop is stopped. Now, the n value is 0. So, when you display the value of n here, it is going to be 0, but then after the function call statement, this statement is executed. When we execute this statement, the n value will remain the same, which is 3, right, because the n value, the n name which is there inside the main function, it is local to that function, and the n which, even though if it has the same name, it is 2 different values, it is 2 different variables. So, the formal parameter just gets the copy of the actual parameter, not the actual value or not the actual variable. So, even though if the value of the formal argument is modified in the function statement or in the function body, which will not be reflected in the calling function, right, even though it carries the same name. So, we can see that the output is going to be 3 initially, because the formal argument takes the actual argument, there we are displaying its value to be 3, and here inside the function it is getting decremented, and now the value of n is getting reduced and it is become 0, and when it is again printed in the calling function, which still remains it to be 3, and the sum value it is actually 6, right. Hope you will now able to be understanding the call by value method. Here, even though the name of the parameter is going to be the same, but actual parameter and formal parameters locations will be different. So, henceforth the value will be handled independently. So, that is what here we are supposed to understand. So, what happens when we create a function and we execute a function? Actually, the memory will create a stack for every function. So, on creation of the stack, whatever the arguments and statements, execution, results, what the function handles, it is all pushed to the stack. So, when the function execution is over, the stack contents will be popped and it is given back to the function call. So, this is how an operating system handles function. So, let us figure it out with an example. So, here I am declaring a main function. In the main function, we are invoking a method called or function called square. So, square is a function here. So, what happens? The function call after step 1, the stack would be on the indicator would be the top of stack. So, we are using an integer variable 10 and it is assigned with the value 10 in the memory, and when it encounters the return location, the stack again releases all the variables and the control is given back to the function. So, this is what happens with the function call in a stack. Supposing if it uses user defined function called square, then the stack pointer points to the function which is active. So, here we can see a main function's variables and the statements pushed onto the stack, and here we can see the user defined function square whose values are pushed onto the stack. So, now we can understand that the actual argument exists in the main function whose value is a. The formal argument exists in the user defined function whose value is also 10, but it is named with the variable name x. So, here we can see that the formal argument is named with the name x and the actual argument is named with the a. In the stack, if you see, there are two different locations given for the calling function and the user defined function. Henceforth, even though the name of the argument is going to be the same, the value or the way it is handled will be independent, right. Then we will learn one more concept called call by reference. What if the location of the actual argument is passed on to the formal argument? Then whatever the changes we do with the formal argument will even be reflected in the actual argument. It means that both formal and the actual argument will point to the same memory location in case if we adapt going for call by reference. So, what we are supposed to do in this case? We are supposed to pass on the reference as the argument, or otherwise the pointer as the argument, the location as the argument. Then the formal argument takes up the location instead of its value. So, when whatever the value which is there in the formal argument, if it is modified, which is also reflected in the actual argument. So, this is an advantage of going for calling by reference. So, we will see with an example. So, what we do here? We are defining a function the same way. Instead of the int variable, we are passing a pointer to the function, and here we can see that we are updating the formal argument's value with respect to a location. So, let us assume that we use a main function. In the main function we declare a variable called number and we are passing on the address of number instead of the number. So, what happens in this case? The address of number will be passed on to the pointer. So, here we are passing the address, right. So, whatever the changes we do with the address will even be reflected in the variable pointer. So, here even though it need not be returned back, the result need not be returned back, instead whatever the changes we are undergoing in the function will even be reflected in the actual argument's value. So, any data intended for y in the function goes to the location of the number in the main program. So, here we are not passing on the value, instead we are passing the location. Since we are passing the location, whatever the updations we do will even be reflected in the particular location. Assume that in this case the location of y is passed on to the variable number. So, which has already got a value 4.0. Now, what I do? I am going to modify the value of number here. So, what happens? The value which is there in the y will also be modified accordingly. So, this is the advantage of passing reference parameters. So, when we are supposed to use value parameter, when we are supposed to use reference parameters. So, value parameters, in case if you want the parameters value not to be changed between the actual and the formal parameters, it is better to go for value parameters. If we compulsorily want the main program to get the parameters value updation reflected in the actual parameter, it is better to go for reference parameters. But we have to be very careful on using reference parameters, because we are trying to use the address, we are trying to use a location. So, that carefully we are supposed to do, we are supposed to handle it. Okay. Now, let us take the same program we have demonstrated for call by value. The same program we will now implement for call by reference, right. The same way I am just assigning the n value to be 3, we are displaying the n value. So, obviously 3 would be printed before function call. So, now we are compute sum is a function call statement, we are now passing the address. In the previous example we would have passed the value as a input, now we are passing the address. When address is passed on, it is received through the pointer. So, using the same loop we are updating the value of n, and n becomes 0 here, right. So, n becomes 0 in this case, right. In the previous example, if n becomes 0, the value was not affected in the calling function, but here when you are trying to print the value of n here, this will print the value to be 0, right. In the earlier example we have seen that the output was 3 here, but it is 0 now, because whatever the changes we do with the formal argument, it is reflected even in the actual argument, okay, if we are passing the value by reference. So, summarizing the function calls we have learnt in this session, we have learnt on function calls, how function call has to be done, what are the parameters, how the parameters list has to be given matching with the function or parameters list of the function definition. When you are defining a function definition and when we are calling the function call statement should go with the function parameters which are defined in the function prototype or function definition. So, it should match with two things, the list of parameters as well as the data type of the parameters and the order in which it is defined. Then we have gone through the way of doing the function call by value. By value in the sense we are trying to copy the value of the actual argument to the formal argument. So, in the function call statement, if you are passing the value will be copied on to the function or as formal argument, and we can make changes in the formal argument which will not be reflected in the actual argument in the case of call by value. In the case of call by reference, we are passing on the reference as an argument. How do we pass on as a reference as a argument? We use the ampersand symbol, we are passing the address. So, since we are passing the address as argument, that is received using a pointer. So, since we are using a pointer, the whatever the changes we do in the function, in the user defined function, I mean in the formal argument, will even be reflected in the actual argument. It means whatever the changes we do with the formal parameters are reflected in the actual parameters too. So, this is what is the difference between call by value and call by reference. Also, we have seen different examples demonstrating the call by value and call by reference concepts. Thank you so much.